Hello ladies and gentlemen, this is Electric Charges and Electricity and correlates with Chapter 18.1 and 18.2 in your textbook. Your key concepts and vocabulary for this video are: how do charges interact? How are conductors different from insulators? What is the difference between the two forms of electricity? And what affects current flow? How do charges interact? Identical to magnets, like charges repel or push away, and opposite charges attract. We can represent the strength of an electric or magnetic attraction with an electric field diagram. The closer together the lines are, the stronger the electric or magnetic field. So here, they're stronger because they're closer together. Here, they're weaker because they're further apart. Earth actually has an a magnetic field that is stronger here at the poles for the north and south. And that is why a compass points to the north and south when you use it, because of that magnetic field. So how are conductors different from insulators? You remember from our unit on the periodic table that metals are good conductors. A conductor is something that allows electrons to flow through it easily. Pure silver is actually the best conductor for electricity, but since it's kind of expensive, we use the second best conductor, which is copper. Now, you'll also remember that nonmetals are insulators, and an insulator is something like glass or ceramics or rubber that does not allow charges to flow easily. What is the difference between the two forms of electricity? We've got the two forms, and they're static and current. Now, static electricity comes from the buildup of charges that get released all at once, kind of like a lightning bolt or when a friend rubs their socks across the floor and shocks you. It's an unreliable source of energy. Then we have current electricity, and current electricity comes from electrons flowing continuously in a circuit. Now a circuit is a continuous loop. It's kind of like a road that you're going in a round trip. As you travel around, when you get back home, you've completed your complete circuit with no breaks. Now, we call that continuous flow of electrons in a material an energy or electric current. This is actually measured in Ampere, which we just shortened to amp for amps if it's plural. Now, the more amps we have, the higher the current. So this basically means there's more electrons passing per second in this section. The less electrons passing per second in that section, the less amps, so the lower the current. Now, there are two things that affect current flow. One is the energy of the charges, and if you've looked on batteries, you'll have seen this 9V. We all know that V stands for volt. Volt is short for voltage. Now, volts, it's important to know that the voltage is the electric potential energy per charge, not total. So the whole battery is not just 9 volts. Each charge in that battery is 9 volts, and that's really important to remember. The second factor that affects current flow is the properties of the material that it moves through. Now we call this resistance. We represent it with the Greek letter omega. Now resistance is affected by four things. One of them is the material itself. So is it a conductor? Low resistance. Insulator? High resistance. The length of the material. Think about drinking a drink out of a long straw versus a short straw. The long straw, it's going to take longer to get your drink. It's higher resistance. Short straw, you'll get your drink quick, low resistance. Also, the diameter of the material affects that resistance. Think about if you've ever tried to drink out of those little coffee stirrer straws. The thinner diameter, it's harder to drink out of. It's also harder for those charges to move through, so it's got higher resistance. Whereas a wider straw has lower resistance, making it much easier to get through. And lastly, temperature also affects it. The hotter the temperature, the higher the resistance. This is generally like if a light bulb heats up too much, it explodes because the resistance got too much. The colder the temperature, the lower resistance. That's it. Please make sure your notes hit all the key concepts and vocabulary.